My name is Trisha L. Andrew. I'm an assistant professor of chemistry and materials engineering at the University of Wisconsin-Madison. We're a half chemistry, half engineering lab, which I'm very proud of. When I started out, it was not that common, but these days it's quite common. And so we make our own materials, and then we actually make physical devices out of them, and we try to be cutting edge in both areas of like designing new materials, new synthetic methods, and also designing new devices. Yulin Peng is a PhD candidate in the electrical engineering department at the University of Wisconsin. She works on making transparent PVs and also PV arrays on flexible substrates, and so she designs the shadow masks and how to connect individual solar cells together, both on a nanoscale and also in a kind of global circuit design fashion, in order to basically make PV arrays out of organic solar cells. Lushui Zhang is a PhD candidate in the materials engineering department, and she has worked on about 8 different things. She is absolutely amazing, and right now she is a person who's spearheading our textile electronics effort. And so she built a system to deposit conducting polymers in the vapor phase by doing, again, organic chemistry in the vapor phase. And she has done some amazing things. Recently, she built a prototype of a glove that has textiles as a thermoresistor, and so you can actually have these winter gloves that heat up your fingers. And so in the winter time when you're biking or something like that, you don't have to warm up your fingers. And then lastly, Ben Pollock is a synthetic chemist. He's not an engineer, he's one of my synthetic chemistry contingents. And Ben came to my lab, I didn't realize this at the time, but Ben came to my lab with a proclivity for something called photochromes. And photochromes are organic molecules that change color with light, and they are the major component of transition lenses, the lenses that change color when you're indoors or outdoors. Ben was doing research on making photochromes when he was an undergraduate at Hope College, and I had this project that we were trying to do. We're trying to beat the diffraction limit. We're trying to beat basic optics and standard physics using photochromes, and he came on board, and that's what he does. He basically breaks the far field diffraction limit by using a thin film of these photochromic molecules to completely change the electric field of light as it passes through.